Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper from the Hugging Face trending list, published on November 20th, 2025, about 2 days ago. It shows that a fully autonomous tool using training loop can evolve a base model with zero human data, boosting the QN38B base model by 18% on mathematical reasoning and 24% on general reasoning benchmarks. The paper is titled Agent0, Unleashing Self-Evolving Agents from Zero Data via Tool-Integrated Reasoning. And as we will see later, the implications for how we train reasoning-heavy agents are quite significant. Also, the authors shared an official GitHub repo for Agent0. Right now, it mainly offers a detailed README that explains the self-evolving framework, its zero-data setup, tool-integrated reasoning, and benchmark gains. The actual training and agent code are marked as coming soon, so the implementation will be accessible there. Figure 1 introduces how Agent0 turns two copies of the same model into a self-improving loop. The left panel shows the curriculum agent proposing questions and receiving rewards based on how uncertain the executor is and how often the executor calls external tools, which means code or other utilities. The right bar charts compare scores and show that this co-evolution greatly boosts math and general reasoning benchmarks compared with the base QN38B model and a simple tool using version. Together, the diagram and results illustrate that the tool-integrated feedback signal actually creates a virtuous cycle, rather than just a static fine-tune. Figure 2 shows how the two copies of the model keep pushing each other to improve through a closed training loop. The top pathway illustrates curriculum evolution, where the curriculum agent proposes tasks, checks how consistently the executor answers them, and gets rewards for confusing, tool-intensive, non-repeated questions. The bottom pathway illustrates executor evolution, where those frontier tasks are filtered by self-consistency, labeled by majority voting, and used with ambiguity-aware reinforcement learning, so the executor gradually becomes a stronger tool using problem solver. Table 1 shows that the self-evolving agent achieves the strongest mathematical reasoning performance across a wide range of exams. For both QN34B and QN38B, the Agent0 row has the highest average score, which means the co-evolution loop really boosts problem solving. Simple tool access already helps compared with the plain base model, but the gains from Agent0 are substantially larger. The numbers across AMC, Minerva, Math, GSM 8K, Olympiad, and AIME contests confirm that this approach improves both routine and very challenging math problems. Table 2 shows that the same self-evolving setup also delivers the best scores on general domain reasoning. These benchmarks, like Super GPQA, MMLU Pro, and BBEH, test broad knowledge and complex judgments rather than just math. For both QN34B and QN38B, the Agent0 rows have the highest overall averages, which means the curriculum plus tool loop generalizes beyond math into wide-ranging reasoning tasks. Table 3 shows that every major design choice in Agent0 actually matters for its reasoning gains. The top row gives the full system, and all the rows below remove one component at a time, which is called an ablation study. When the curriculum agent is not trained or loses its tool reward or repetition penalty, both general and math scores drop sharply. When the execution agent drops ambiguity dynamic policy optimization, a scheme that trusts uncertain pseudo-labels less, performance also falls. Finally, removing multi-turn reasoning further cuts both averages, confirming that step-by-step tool use is crucial for the strongest results. Figure 5 shows that the self-evolving loop actually produces harder, richer tasks, and a solver that can handle them. The left side lists example questions from 3 training iterations, which grow from simple geometry to a multi-step, combinatorial-style city routing puzzle. The right panel walks through a standard math test question, where the agent first reasons in natural language, then runs short Python code to verify the pattern. This hybrid of explanation plus code execution illustrates how tool use turns abstract reasoning into checked, reliable answers. Agent0 shows that a model can bootstrap itself from zero human data, as long as it co-evolves a task-generating curriculum agent with a tool using executor agent. This points toward future training pipelines where agents discover, grade, and solve their own hard problems. That is it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.